Welcome to DABCC Radio,
where smart people listen.
Virtualization and Cloud Talk,
Featuring cutting-edge solutions from the hottest companies around the globe.
broadcasting from the DABCC offices in sunny Sarasota, Florida.
Surrounded by computers, books, and Legos.
A Microsoft MVP, Citrix Charter CTP, VMware vExpert.
And your host, Douglas Brown.
Hello, everyone, and welcome to DABCC Radio. I'm Doug Brown, and we have a great show for you today. We have our third installment of a series we did with DataCore Software about their amazing virtualized physical, you name it, storage solution. Parallel IO. You guys, if you have not listened to the other two podcasts, they are some of my favorites. In this one, we have a gentleman from DataCore, Jeff Slapp, who's the director of systems engineering and a few other things over at DataCore. And this guy's brilliant. Guy's brilliant. In fact, we've had three people on from DataCore, and they're all brilliant. So three of my favorite podcasts. I think you guys will love this. Just a really deep dive into storage, into what's happening I'm sort of speechless, to be honest with you guys. So it's really a great episode. Jeff is an amazing man. So with no further ado, let me dive into my interview with Jeff Slapp from DataCore Software. Okay, Jeff, thank you so much for taking the time to do this. I've really enjoyed chatting with you, just, setting up the podcast. You are one passionate man about what you're doing, aren't you?
Yeah, thanks, Doug. Yeah, there's a lot going on in this space. A very exciting time.
It's definitely an exciting time, and especially in IT in general, but in storage. Just crazy what's going on, and we're going to talk just about one area, or we'll probably talk about a lot of areas. But we have an agenda for today, and I'm really looking forward to this. You're a brilliant guy. So, with no further ado, let's dive into it. For my first question, as always, who are you, and what do you do at DataCore? So, Jeff, who are you, and what do you do at DataCore?
Yeah, thanks, Doug. So my name's Jeff Slapp, and I'm the Director of Systems Engineering and Solution Architecture for North America here at DataCore Software, located in sunny South Florida. Our headquarters in Fort Lauderdale here, right next to the Citrix World headquarters. And so my team for North America, we are very much involved in the pre-sales effort. My solution architects, one of many responsibilities they have, but their principal role and responsibility is to assist our sales directors in putting together DataCore-based solutions. And as the audience may be aware, of course, DataCore is a software-defined storage company. So, of course, the software, being software, is highly flexible. So that requires, for various customer use cases, a lot of discussion, a lot of interaction around putting together the right solution for clients to get the maximum benefit in their architecture.
Awesome. And you had mentioned DataCore real quickly. And my second question was going to be, tell us about DataCore, but you sort of answered that. Anything else to add around, what you guys are, who you are, and what you guys are doing? There's a lot to add around there, right? Of course.
Lots to talk about, but I'll keep it short.
Sure.
DataCore, again, software focused, obviously around the storage industry in particular. We've been going at this now for 18 years. In fact, it's a very interesting tidbit. We started the same year VMware did, back in 98. And, of course, VMware took the approach of virtualizing and abstracting the compute layer. And effectively, we do very similar, except that we're at the other end of the stack at the data and the storage layer. So we provide that very high performance and highly available storage abstraction layer that can, of course, consume and manage really any type of storage that we can see, that anything that's presented to us. So makes for a very interesting conversation in this world that we live in, that not only is highly virtualized, but now this software-defined everything movement that's happening. It becomes a very interesting time to do business.
Absolutely. Well, today you wrote an interesting article a while ago called "Hyper-converged: A Noun or a Verb." And I saw that, and I was like, well, wait a second, I got to read this. So I'm really excited to dive into this, this idea you have, and learn more about it all. Right. So with no further ado, let's do that. Let's dive. Or well, before we dive in, could you provide our listeners with a basic definition of hyperconvergence? When cloud came around, I asked, what does cloud mean to you, right? Because everyone had a definition. When virtualization, what does virtualization? Everything was virtualization, right? So what is hyperconvergence? How do you define that?
Yep, excellent question. And just even before I get into that, like you had mentioned earlier around the cloud, I remember those discussions. It was very interesting because very similar to what hyperconvergence is, cloud, the reason why everyone had a hard time defining what it was is because it was 3 or 4 different things, right, depending on what perspective you were taking. And very similar to hyperconvergence, well, hyperconvergence, at least from a DataCore's definition perspective, right, I think this is very generally the case across the board, is when you have the ability to take the application and, of course, bring that onto a server platform, as it tends to be, and then also marry that with the storage services, the networking services, and so on and so on and so on. And of course, the deeper dives into each one of those areas, of course, will be highly variable depending on the customer's requirements in their environment and so on. But generally speaking, those various layers now all coincide on the same piece of hardware. And of course, the argument that I'm making, and many of us are making now in the industry, is that hyperconvergence is not something that you go and pick off of a shelf and that you buy and acquire, right? Hyperconvergence is actually something that you do. And of course, the doing brings into question, well, what tools do I have to accomplish that task? And of course, DataCore is a very important piece of that discussion, we believe, in the capabilities that we're able to bring to bear on that type of architecture. So
that's interesting. I've never really thought about it that way, but I guess, it makes a lot of sense. So why would an organization be compelled to deploy a hyperconverged architecture? What are the benefits of hyperconvergence, especially within, your space?
Yeah, so that's of course a very good question that I think everybody's asking today, because we see there's a lot of discussion around this, and of course everybody has a different view on maybe how it should be done or what it should be done with. We feel that because DataCore is unique in the sense that we are truly software only in our nature, right? We're not bound to any sort of hardware construct, and we'll also talk about this new emerging model that has come out of our labs in the last 6 months or so, which even further extends the idea of hyperconvergence into a whole nother area. But hyperconvergence, of course, it's really made up of those pieces that we mentioned earlier. But it's from DataCore's perspective, when you take software, which of course is independent of the hardware, and now you give the consumer, the customer in this case, the end user, the choice of what to hyperconverge and how to hyperconverge, right? Then that opens up again a whole field of options that may not be necessarily available for the take it off the shelf type solutions, right? We try through software, of course, the whole idea, the whole premise around software, at least, again, I'm speaking from DataCore's perspective here, is to avoid the box-in, to avoid the lock-in, if you will, on any particular platform, because one of our major mission statements around our product development, and this has been the case since day one, is we believe that software should advance and evolve independently of the hardware. Now, we're all based on standards, right? DataCore abides by the same rules of computing and storage and all the things that happen inside the box, just like everybody else. And of course, just like the hardware is based on standards. So if we've taken that approach, which is what we have done over nearly 2 decades now, that means that we've actually achieved what our goal was when we set out, which was as our software advances and continues to bring benefit and higher performance, high availability, and all the features that surround those capabilities, we can then also equally exploit the hardware, which is advancing at a different rate in a different way, but yet there's no change in the standards. So as long as the standards stay the same, which they have been since the beginning of computing for the most part, then both worlds are going to be able to coexist seamlessly, and the customer, of course, will be the recipient of the benefits of both of those advancements independent of one another. So that's kind of the full circle analysis from DataCore's perspective. But when you look at hyperconvergence today across the board, there typically is an assumption that obviously first, and it's a good assumption, right? You have to have hardware, of course. Hardware completely void of any intelligence or any software or firmware or some sort of instruction set is completely useless. Just like having great software void of hardware is equally useless, right? But you need them together. But again, that doesn't mean necessarily that they have to be tightly bound or tightly coupled, as we refer to it, and locked in. And a lot of what you're seeing, at least what we're seeing in the software-defined storage space, is that while, yeah, it's called software-defined over here, there's an awful lot of hardware lock-in over here, right? So we've almost kind of traded off some of the flexibilities that the software was originally intended to bring. We've actually negated some of that. And that, of course, if you stay true to the mission statement, that's something that we at DataCore will continue to push as an idea, is full flexibility. You asked about the elevator pitch earlier. It's funny. There's a little bit of a history around this, and I'll just give you the brief version of it.
Please.
People say, well, give me the 5-second elevator pitch. What does DataCore do? And DataCore has been called a lot of things. I think most recently the most interesting one is the Swiss Army knife of storage, which is great, right? But the problem is that if you try to sell a Swiss Army knife based on all the features, it becomes a little bit too much, right? Because after 18 years of development, you can imagine we have a lot of tools in the toolkit. So what we've done is we said, well, we're now 18 years later in the discussion. Back in 1998. If I said to you what I would say today in the elevator, well, DataCore does for storage what, say, VMware does for compute. That's a perfect example, right? Because everybody knows about VMware. Everyone understands basically the benefits of virtualization. So I can say that today, but if you said that 18 years ago, they'd be like, who's VMware and what are you talking about, right? That conversation wouldn't be a 5-second elevator pitch. It'd be more like a 5-day-long conversation.
Sure.
So again, that's all around the idea of the benefits of staying pure software and allowing, of course, now to run on any generation of hardware today, 10 years from now, 20 years from now, and beyond. And that's a very powerful proposition that we at DataCore are trying to maintain as we progress through all of the different models that have emerged: traditional storage systems, converged or server SAN, hyper-converged, and then the new one that has been emerging and we're actually now deploying in the field called hybrid converged.
Interesting. Oh, real quick, let's sort of take a step back. You keep mentioning software only, and I understand the DataCore solution, but maybe a lot of us probably do, but maybe there's some that don't. Can you sort of explain what the DataCore product in the sense of, it's a hard question to ask almost, Jeff, but what is it? Does that sort of make sense? So we can explain what you mean when you're saying it's software only.
Right. Well, if anyone, you take a general server today, right? Everyone's probably very familiar with the internal workings of the server and the components that make it up. You got CPU that does the work. You got the RAM. You got the disks. You have some sort of network connectivity, right? So those 4 components are pretty consistent. Have been consistent for a long time in computing, and certainly in generalized commercial computing. So what we do is, because DataCore is, again, one piece of that puzzle, a very important piece as it turns out, because DataCore provides the virtualized storage services, if you will. Now, what's special about that? Well, again, if you think about VMware, and again, for those who may not be familiar with DataCore, when you think about VMware, what does VMware do, right? VMware is a piece of software, right? It's a set of instructions. It tells the hardware what to do. And in this case, it's a very specific piece of software. It's a software-based hypervisor or an abstraction layer that allows the workload, your application, to run now loosely coupled with the hardware. And of course, one of the most profound features probably in the last, I guess now, 10, 12, 15 years is the idea of vMotion, right? The idea that you can take a running workload that's doing something right now for you, right? It's a database, it's a file system, it's a whatever web server. It's actually doing something for you. But the idea of picking that up and transplanting that to another physical system, while it's running with no interruption is absolutely baffling, and it certainly was at the time. And I think we still, even today, take it for granted what it's actually doing. Right? It's an amazing feat of technology.
Yeah.
So that's, of course, one of many benefits of having a piece of software, in this case a hypervisor, doing that for you. Well, now imagine at the other end, the other piece that tends to be, up until the modern times, tends to be very tightly coupled with hardware, of course, is the data. Hence why we called our company 18 years ago DataCore, right? Because data, at the end of the day, and hopefully I don't offend anybody by saying this, but I think it's reasonable that without the data in your data center, there really is no need for all the routers, the switches, the servers, the connectivity, right? It's all serving to get access to the data. Again, a little history around why the company was called DataCore. So we are that software hypervisor, basically, right, in the simplest sense, right, to draw the parallel to what VMware and Hyper-V and others do. But what we do is we abstract, or we decouple now the data from the storage system, so that now it makes no difference what the storage system is, right? And so now you can have very high-performing storage, flash devices. You can have 10K, 15K, nearline disk, SATA disk, SAS disk, anything that you can present us through any connectivity model. We can take that in now and unify it and apply a very, very powerful set of common universal features across all those different makes and models and types of storage, making it appear as if it's a single homogeneous storage platform. But then where the equivalent vMotion example I gave you at the VMware level comes in is that now, because that data is not tightly coupled to the disk, that means that now adding, removing, expanding, repositioning data, that is just a very, very basic function, 101 DataCore function that happens, that gives you complete control now of what that underlying storage platform is. Because as you know today, you look around, we're not talking about tens of gigabytes of storage anymore. We are very commonly now talking to customers that are entering into the petabyte level scale of storage. Certainly in the several hundreds of terabytes, right? That is becoming very, very common now. So the idea that you just have a single frame or silo of storage is just not something that you see anymore, right? Most enterprise customers today actually have multiple vendors in place simultaneously, but the problem is that they're islands to each other. And of course, DataCore works very hard and has perfected this method of now breaking down those barriers. And instead of having islands now all of your storage works together for the benefit of being able to deliver the data to the upper layers as quickly and as highly available as possible. So that's the easiest answer I can give you to your question.
That's why I ask it. That's an awesome explanation. I knew you would give me an awesome explanation. I love it. I love it. So you say high performance is not an advantage associated with hyperconvergence. This is sort of weird for me, as I always thought that hyperconvergence did give us high performance, or it helped give us high performance, right? Why do you say this? Can you explain?
Yep. So it really goes back to, again, the mid 2000, 2005 era when this happened, when then this transition occurred in the industry, and I'll try not to go over the deep end with the history lesson, but there are some key points here to note. Please
go over the deep end.
Okay, so there was a pretty significant shift that happened in 2005. As you know, 2005 was the advent, at least from Intel's perspective, which is the world that we live in at DataCore. Yep. From the Intel processor perspective, right? The Moore's law took a deviation, right? We couldn't process any quicker, right? The scaling, the frequency scaling that was occurring on the CPUs just couldn't be pushed any further from when you took into account the economics. It's not that we couldn't do it; it's just that economically speaking, there was a somewhat of a natural barrier there. But that was okay, as it turned out, because, as you remember, by that time, in 2005, technologies, database technologies principally, but also, of course, this concept of VMware had been around for over 7 years then at that point. So this actually helped give birth even more justification to the idea of going and taking the concept of multicores into account. Now, and where I'm going with this is a very important transition here. So what VMware and databases and applications at that time were becoming were highly parallelized, right? They were becoming very concurrent in nature, right? Whether it was a really big, massive database that was doing all kinds of number crunching and reporting and, what we call today analytics, very popular term you hear in big data circles, certainly. A lot of crunching had to be done against that data. That, of course, was very highly parallel already, but that I/O was being driven very serially to the storage system. And I'll give you a proof point around why this is actually the case in a minute. So when multicores came onto the scene, of course, and then of course, VM proliferation started to occur, right? VMs started sprawling everywhere. It was so easy to create a VM. So now you might start off with maybe 50 VMs, and then a year from now you have 500 VMs, right? Because it was very simple to do. And of course, then processors continue to get more powerful. So those industries played off of each other very nicely, as it turned out, right? Having more processors was a good thing. Not just faster processors, which we'd hit the limit on, but more of them, which was great, right? And driving even more concurrency. But yet we still haven't been able to solve the problem of storage. Now, in 2005, the industry knew that there was a problem. The problem was, and it really around the acknowledgement that, our storage is the bottleneck, unquestionably. So there's two ways we can go. We can either go down the road of throwing out all of our code, which is all written for single processors and serial processing generally.
And that's not going to happen.
And that's not going to happen, right? That's a massive undertaking, right, to throw all that out and start over. Because, just the idea of going parallel from a code perspective, and you and I are both developers and obviously working for a software company, we know firsthand the difficulty in doing storage programming in general. But to have a parallel storage programming system is very, very, very challenging. So takes a high degree of expertise that really at that time it was referred to as the lost art, right? Symmetrical multiprocessing and parallel processing and programming around those systems was something that universities really weren't teaching that much of, and still even to today, for the most part. So there's again still pretty much a lost art in the industry. But so what I'm trying to get to is this: the industry had to make a decision, right? Do we recode? Not going to happen, right? We know that didn't happen. So the alternative was to start leveraging a technology that we had for 25, 30 years at that point, not as well known in the mainstream, very, very expensive, but could at least Band-Aid the problem for some time. And that, of course, is the advent of the availability of solid state and flash and those sorts of technologies. Now, the problem was that they were expensive and they didn't have a lot of capacity. Of course, now that today, you fast forward many years now, 10, 11 years, and that problem has been solved, but now another problem has emerged. Well, if you notice, when Flash came onto the scene, you notice the transition. If you look back over those years after that occurred, now you start to see something else happening. The industry is like, they recognize that having a fast storage device is a good thing, right, to a certain point. But the other issue is the proximity of that storage to where the I/O was being generated in the first place, which is the CPU. So now what have you seen happen, right? SSDs come onto the scene, and typically they're put into storage arrays. And then someone says, no, let's move the flash up into the RAID controller inside the server. And then someone comes along and says, well, let's go ahead and put the flash on the PCIe bus, right, really close to the CPU. And then someone says, well, let's go ahead and put the flash right inside the DIMM slot. Well, unless there's a major change to how CPUs are architected, that is probably as far as you're going to go for some time. But you see the acknowledgement, right? Without having to say it, there was an acknowledgement in the industry that it was more than just having a fast disk. We had to bring it as close together with the CPU as we possibly could. Yeah. And that's, of course, what you're seeing now. And certainly with the next generation Intel architectures, that is certainly going to be something that will be a more standardized option for server manufacturers now with the next generation that's coming out. That's also very exciting. But the good news was that DataCore, of course, saw this coming 18 years ago. And you notice over all these years, what's happened, of course, is we've transitioned again from traditional to converged to hyper-converged, now to hybrid converged, and who knows what it'll be 5 years from now. But the strength of DataCore is in this. Because we have stayed true to the software-only model, it does not matter what the underlying hardware construct looks like, right? As long as the standards haven't changed, We will work the same on a bare metal system with 2 processors as we will with a bare metal system with 200 processors. Inside of a VM, in the cloud, makes no difference where we're running because it's all based on the same fundamental construct of how computers and storage work. So that means, again, going back to what I said earlier, we can advance independently, and you can get a more than a twofold a benefit across an environment as each generation comes out. It's not a linear increase in benefit. It's actually an exponential increase in benefit, which is great for the consumer. So, sorry for the long answer, but there was a lot to say there on that particular question.
No, and never apologize for a long answer. That was a phenomenal answer. This is what I love about DataCore. You guys don't come here and give me marketing stuff. You guys come here and blow my mind with deep technical that I need to think about and then research. So never feel like you need to give a short answer. Please. So
there was one more thing I want to make sure I'm clear on to close out the question around the original question. Now that I gave the full dissertation on it, was more specifically attributing high performance with hyperconvergence. Now, after everything I just got done saying, now hopefully this will become a little more clear, is that, again, because void of DataCore, these systems are again still severely handicapped in their ability to process storage I/O. Okay, the fact that you're moving some disks or some flash up closer now helps a little bit to move that bottleneck, the width of the bottleneck a little bit more, but it doesn't fundamentally change the way the I/O is processed, and that's of course something that DataCore has spent an awful lot of man hours on. I couldn't even guess, right, of the millions of man hours over all these years that have been spent on tackling this problem. And this, of course, is where we start talking about this concept of parallel I/O processing. And it's very, very important. In fact, we saw a very clear demonstration of this on our most recent SPC-1 run that we did back a couple months ago, where DataCore set the world record not only for the fastest all-out I/O ever recorded by the SPC-1 at 5.12 million I/Os per second, but we did it at a latency that was very shocking. It was in the 200 to 220 microsecond range in there. And we also then simultaneously did it at a world record-setting cost per I/O. So when people say, well, how do you explain that? I'm like, well, it's sometimes in technology, what you'll find, actually most times in the world, with anything that you apply this to, if you go faster, usually there's a higher cost associated with that, right? So if I want to go 280 miles an hour, I'm going to go out and buy a Bugatti Veyron, but I'm going to spend $2.5 million to do it, okay? But what DataCore is proposing, and this is just purely from a performance perspective only, right? We're not talking about all the other areas we affect, just performance. We're the Bugatti dealer that goes in and says, hey, we'll sell you this Bugatti, but you know what? We got a great deal today. Instead of $2.5 million, how about $30,000 as an example, right? Because the economics are so staggering. Of course, your reaction is, okay, what are you trying to pull here?
My reaction is I'll take 2.
Well, hopefully that too, right? But most people react very, very shocked, right? And this is what I call, when I'm done talking with folks, this is usually what I refer to as the DataCore Enigma. Because how many times in your life, in any area of your life, can you both simultaneously have the best of something at the lowest cost, right? They are at opposite ends of the spectrum. They usually are very much at odds with one another, right? You would agree?
Yeah.
So how do you have a system that seems to defy what we understand, right? The old adage is, right, if it sounds too good to be true, it probably is. Well, in this case, it's not. And what we did, what was very important for DataCore to prove, was that this was not something that was, the unicorn, if you will. It was fictitious, right? This is real, and we use the SPC-1 to prove that. Even though most people don't even know what the SPC-1 is, the real propeller heads in the industry, of course, know that it's the standardized storage benchmark that is very highly sought after and highly respected because of its history, because it's audited, because all the major vendors are a part of its council and part of the council membership. There's an awful lot of eyes on there. So if anything's not going to pass muster, they're going to find it, and then they're going to bring it to the table. But when you actually make it onto the top 10, or in our case, we're on several positions on the top 10, not including number 1, that at least at a minimum has to force you to say something about DataCore. You have to come to this conclusion. We're clearly doing something different. I mean, there's no question about it.
Sure.
Right. So that again is a very good explanation again around when we talk about hyperconvergence. The hyperconvergence story is, first off, well, yeah, I'm consolidating. Consolidation is good, right? I mean, again, we have to keep doing the same things that we're doing inside these boxes, right? We can't get around networking and processing and storing. We've got to do all those things, but we just do it in a tighter package. That's a great story, especially when you're trying to consolidate, real estate and do more with less, because that's certainly our model, right? Doing more with less. I think if anybody can say that, DataCore can. So, but it goes one step further, because now when you have a storage subsystem like DataCore, an I/O processing system, a parallel I/O processing system specifically, now meeting a very highly parallel application workload, right? High levels of concurrency. Now, effectively, what you see, the easiest way I can explain it, is that the storage no longer now becomes the bottleneck. It actually becomes the CPU. And that's precisely what we're seeing now when we run these workloads. We are running the CPUs so hard, and it's not that DataCore is necessarily chewing up all the CPU. The application is running absolutely full tilt because it's no longer being held back by the storage. And that is true, by the way, for any type of disk that you see out there. We can drive spinning disks harder than most people can probably even believe, because the way that we talk to the disks is not the same way that your application would. By the time the I/O gets from the application, whether you're talking hyperconverged or any other model, by the time that I/O gets down through us to the disk, everybody's marching in single file lines, and there's multiple of them, and everybody's very orderly, and everyone's getting along, and we're not having this just mash of I/O, or the I/O blender as it's referred to, being thrown at the disks, which is precisely why, by the way, when you look at the SPC, in any storage system for that matter, in order to get better performance, what's the typical knee-jerk reaction? Well, I got to throw more hardware at it, which is precisely why. And when you look at the SPC-1, when you look at who we beat on the SPC-1, they had 4 racks of all flash, right, combined. Almost $4.5 to $5 million worth of hardware, all flash, top to bottom. 168 rack units, I believe, is what it was. And when you look at that and you compare that now to what we did, we doubled the performance. We beat the previous 1 and 2 record holders combined, and we did it with 14 rack units of hardware, 2 servers and 2 JBOD systems attached to each one of those servers, with a mix of some of the cheapest SSD you can possibly get your hands on and some spinning disk. The point is that the I/O is being parallel driven, and we're taking the opportunity to put all the optimizations in so that by the time the I/O gets to the disk, you don't need to have necessarily very exotic type disks, because we're handling and reordering and optimizing all that for you at the software level, and we're doing it across the multitude of parallel processors that you have in the box, which today you can put as many as 192 logical processors inside of, say, for instance, a Dell R930 or a Lenovo 3850 or those similar types of classes of systems. It's tremendous. The horsepower is there. It's just that you need the right software to get at that, to use it for the right purpose. Yeah. And the last thing I'll say is, when you bring the application, which is the I/O is being generated at the CPU level, and you bring that storage system up, and you also now run the storage processing on the same CPUs where the I/O is being generated, that is fundamentally as fast as you can possibly go. You can't get any closer. So everybody that's been trying to move closer and closer to the CPU, DataCore achieved that 18 years ago when they decided to do storage processing on the actual CPU itself. There is no closer than that. And of course, that affects latency, and that has a tremendous impact on not only the density, but also the application response times, which of course is the true marker of storage performance. So thank you for allowing me to elaborate even further. There's a lot to say about it.
That's phenomenal, Jeff. Just phenomenal. Guys out there listening, if you're enjoying this and want to learn more about parallel I/O too, we did a podcast just recently with the DataCore, one of the co-founders and CTO, Zia, who really dives as deep as Jeff is now into Parallel IO. And I highly recommend that podcast. It's phenomenal education on both what DataCore is doing, but just Parallel IO in understanding what this is, how it works, how they do it, all that jazz. Zia is a phenomenal man. So highly recommend that podcast. I think you guys will really love it.
Yeah, I've known Zia for, 13 years or more. And I can't say that there's a single person on the planet that I've learned more from than Zia Oral. So he definitely check that podcast out, and any other material, which there's quite a bit of material out there that he is, of course.
Anytime you see his name, you stop, drop, and roll, right?
Yeah.
So,
it's a good way of saying it.
Yeah, that guy's phenomenal, just phenomenal. So that being said, you talk about how sometimes there's an opportunity to consolidate the entire enterprise into a hyper-converged architecture, but that more often is the case that the hyper-converged solutions comes with an operational and functional barriers. Can you explain these barriers? And, of course, I imagine DataCore solves that, right?
Sure. Yeah, so, I mean, one of the things that we see very often is when we talk about folks that are looking to go hyper-converged, and there's many reasons, right? Everybody's got their own set of reasons why they go down this road. What we find, of course, is that it typically is not, in most cases, at least at the enterprise level, we talk with a lot of enterprise folks every day. I'm on probably 10 or 15 calls a week, just myself, dealing with enterprise-sized customers and talking about this idea of hyperconvergence and, of course, the follow-on of what comes from that. And it's almost never a complete all or nothing proposition, right? It's always going to be, well, we have a workload over here. We think this would be good for it, but we still got to keep all this other stuff which can't be hyper-converged, right? So now again, all you're doing is you're just creating yet again another island, right, in the system. And while it may be good for this particular workload over here, there's still a whole bunch of other stuff over on the other side of the room that can't take advantage of that. And of course, that again not only brings additional complexity to the environment, not only from a management perspective, but just straightforward operation of the environment. It just continues to expand that complexity. And of course, the whole point again around software, at least the staying true to the mission that DataCore is trying to do over all these years, is to try to simplify life, right? Is to bring as many things together as you can and ease the management, right? Reduce what we call, we jokingly say sometimes, we reduce the number of mouse clicks that you need to go through to get something done, right? Most of the very, very heavy lifting operations that you can do inside of our software today can be done in less than 4 mouse clicks, right? And that's literally from moving in volume from one side of the world to the other, or forklifting the data from one vendor storage array to another. Things that had traditionally been very risky, very challenging, very time-consuming. Now is just a matter of a couple mouse clicks. So again, if we have done that, then we've certainly accomplished our goal of making life easier, operationally speaking. But going along into the same lines of what we were just talking about with regards to having those split environments, and that's typically what we run up against. And there's a couple things to say about this. That in and of itself is a problem. But what we find, again, staying true to software, is that the advantage that we have is that you see this, perpetual pendulum, if you will, right? Where it's just constantly swinging back and forth in the industry. Where, if you think back, go back to the late 70s, early 80s, that time frame, where we had this idea of mainframes and terminals, and then everything moved from the data center back to the desktop, and then the desktop back to the data center, and then the data center back to the desktop, and so on and so on and so on and so on. So such is the case with all the areas of technology, right? So what happens is that all these environments are in constant motion. They're constantly, again, like a rubber band, right? One pulls, the other side gives, the other side pulls, the one side gives, and it's this back and forth. Well, being software, of course, allows us now to interoperate across whatever that paradigm is. It doesn't matter what it looks like. It doesn't matter how big it is. It doesn't matter how scaled it is, how vertical or horizontal it is. It doesn't matter what it's made up of. Again, as long as the underlying technology, the fundamentals haven't changed, the standards haven't changed. So what we say now, and this is something that is very, very exciting for DataCore, something that has emerged, and I think has always kind of been there, except that it's just one of those things. Again, it's not until the industry needs it that it actually becomes something that, jumps right out at you. But something that has come out very interestingly from our SPC-1 testing over the last 9 to 12 months or so in the lab is, and this is something that you're not going to see in the SPC-1 benchmark results when we run this, right? This is something that can only come from someone who actually sat there and watched it run, which I did, and of course Zia and all of our engineering teams did. And it's very important. We don't appreciate the full power that's inside these systems today, the magnitude of the processing power that is available to us. And every generation that comes out, there's even more processing power that's sitting there that's untapped. So, and this is a perfect example of this. When we ran our world record run of 5.12 million, when you looked at the CPU utilization of these systems, the two systems, by the way, that we were running on, and that was all the boxes were doing. And these were based on Intel E5, I believe it was the Haswells, the V3s. These weren't even the Broadway or the new ones, right? The V4s. So when we ran to full load, we found that the CPUs were only 50% utilized. Now, of course, the natural question to this is, well, why the heck didn't you just drive this thing to saturation, right? Wouldn't that have been a better number? Well, it would have been, but the problem is that remember now we were using 2U servers. We simply had no more slots available to us to drive, fiber channel ports, right? We had no more slots. We had no more ports to use, right? Everything was fully used and fully saturated at that point. Couldn't do any more. Even though the box was sitting there saying, come on, guys, give me more. Give me something else. So what was birthed then, what the idea that emanated from that discovery? Well, a couple things. One, I already said, the tremendous amount of horsepower that's available to you. But from a deployment perspective, from an architecture perspective now, what became very apparent was that this idea of being able to simultaneously run ridiculous workloads externally to the system and still have enough horsepower for any applications that you may want to run hyper-converged, this is now what we call hybrid converged, because now we've just proven, and of course this will be even more the case as each generation of processors comes out in the future, we've just proven that we do very, very well. That's great. But we also now have the ability to now exploit the hardware even further by running localized workloads, which, of course, when you localize those workloads, remember, you're running the applications as close to the storage processing system, in this case DataCore, as you possibly can, which means that you might have very high-intense workloads that need ultra-low latency. Put them right on the box. And then for everything else that is not able to be, quote-unquote, hyper-converged onto that system, we still have more than enough horsepower to serve out block storage, enterprise-grade performance block storage services out to the rest of the network and rest of the fabric that you have in your environment, now fulfilling both roles and avoiding the need to have this one-off solution for this one case and then, again, all the other stuff that we have to deal with in our enterprise for everything else. It now unifies the model significantly. And again, why wouldn't we do that? All that horsepower is sitting there begging to be used, and you've already paid for it.
Yeah.
Let's go ahead and bring to bear on that hardware the right software to exploit that capability. And that, of course, is, we're trying to shout this from the rooftops, right? This is what we want everybody to understand is what they have available to them if they have the right pieces and parts to pull it off.
You got it. I asked you earlier to sort of explain the DataCore, software solution, but I have a sort of similar question, but it's related more to the hyper-converged solution. And can you please explain what a hybrid converged model with DataCore looks like?
Yeah, so the hybrid, which I just referred to, is the idea that, if you look at DataCore 101, right, before all of this convergence and everything else came about, right, just look at DataCore, the way that we originally were typically deployed in the enterprise. You would take a server, an x86-based system with some amount of CPU, RAM, disks, whether it was inside the box, outside the box, doesn't matter. And, of course, you have the ability to serve that storage now, the storage that we are presenting, out to the rest of your application servers, right? Your VMware servers, Hyper-V, AIX, HPUX, Linux, Windows, everything that's out there. Okay, that's what we typically refer to as the traditional model of storage, which we've all known for many, many years, right? When you buy the big frames of storage, that's really what you're getting, right? You got a capacity layer, you got the controller layer, and then you've got the application or the consumer layer. And those are very well-defined distinctions, right? They're not merged in any way. Well, of course, as you transition from traditional and as hardware advances, of course, right, as the hardware starts to become denser and higher capacity and faster and all these things, of course, that just naturally happen over time. What now has happened is that has now evolved into what we have called in recent years Converged Fan, where now we have a tremendous amount of capacity inside of say, even a 2U server. Today, I can put well over 100 terabytes of usable capacity inside of a 2U system, which is absolutely amazing because back in the days when I used to work at Iron Mountain, we would fill rooms of very, very large frame-based storage systems that were totaling into the hundreds of terabytes, and it filled rooms. Okay, now you can get it in a 2U form factor on a very common server that you can buy from any vendor out there. Right? It's amazing. So that's what I mean by the evolution of these things. As they start to evolve, we start to do all these different models. Hyperconvergence was the natural evolution then of that, but now looking at it from the processor's perspective, right? Ever since 2005, the number of cores and the capabilities of these processors now has been tremendous in their growth and in their availability. And now it's common to buy a server that can have as many as, I believe the latest generation, as many as 22 cores. So you could have 44 cores of processing power running at 2.2 gigahertz. But really, those 44 cores are really 88 logical processors, which would be seen by us in VMware and other hypervisors, right? They would be seen as 88 distinct processors, which can be used for running your virtual machines. So it became very apparent that we had a ton of CPU horsepower sitting there. Let's go ahead and now bring the applications down, right? VMware, Hyper-V. And I will also extend this, by the way. The hyperconvergence definition from DataCore doesn't just include hypervisors, although that's the most common case. We also are talking very heavily today to the Oracle folks, to the Microsoft SQL folks, to the DBA community as a whole, because what we're seeing when you hyperconverge just the database, right, not the whole myriad of all the virtual machines, but just the database, bringing that down as an application and bringing DataCore in as the storage layer in a hyperconverged solution from that perspective, the performance is absolutely staggering. The performance gain, that is. Not only the amount of IOPS that are available to you for processing, but principally the latency now that you're able to achieve in this model is nothing short of absolutely game-changing. And we demonstrated this out at VMworld this year. We have many videos on the website, on YouTube, and others that talk about this and show this. And you'll be seeing that happen a lot more. And that's a model that's picking up very, very significantly for us in that space, especially in the database community, and of course all the verticals in the industry that use databases very heavily, healthcare being one of them. So that, of course, is the hyperconverged explanation. Hybrid converged just simply is the marrying of the two, hyperconverged and traditional. Because again, going back to the discussion around how we have so much horsepower available to us at the CPU layer, there is so much there, and every year Intel continues to add 20% more. Well, we now have the ability to be able to run those localized workloads like I just explained, whether it be right on the bare metal right next to us or whether it be inside of a virtual machine, makes no difference. But then also simultaneously serving out the same storage that those applications are using locally out to the rest of your network or your fabric for other consumers to take advantage of that storage, and of course the high availability aspect and the performance aspect, all within a single within a single solution, instead of having to have different solutions for all these different use cases. So now I say that because we're at 4 today, right? Traditional, converged, hyperconverged, hybrid converged. Who knows what the 5th, the 6th, the 7th, the 8th is going to be, but it doesn't matter to us because whatever that next advancement is, DataCore is right there ready to take advantage of and exploit that hardware to give you the maximum return for that investment. And we do also see, by the way, obviously, like everyone is seeing today, the huge push into the cloud. This might be a topic for another podcast, but the things that we're doing inside of the Oracle clouds, the Azure cloud, AWS, is again just as mind blowing of what we're able to achieve inside of virtual environments. So we'll leave that for another time, perhaps.
Oh yeah, absolutely. I bet that is very interesting. So, I just saw today. I mean, just before, literally this morning, before we started this podcast, an email come through with a press release from DataCore about a partnership with Supermicro around hyperconvergence. What is this?
Yeah. So we've been working with Supermicro very closely over the last several months, and they really see a pretty significant market to be able to take their platforms and go after, of course, hyperconvergence being the first entry point, but of course it spreads like wildfire after that. But since hyperconvergence is such a hot topic right now, and everyone, again, going back to the whole reason why we're talking today, right? I think people are realizing that hyperconvergence is a verb, right? It's something that you do. It's not something that you go and buy off of a shelf. And of course, people are realizing this, and certainly our partners are realizing this. And so we've been working very closely with Supermicro to put together some models that fit a pretty wide range of use cases, whether you're talking about virtualization or whether you're talking about database hyperconvergence, like I just got done explaining, or all the above, right? The benefit is, of course, of the partnership. The Supermicro makes some extremely flexible hardware configurations. Again, right, we love flexibility here at DataCore, so naturally, when you get the two together, you have a very, very highly flexible hardware platform together with an extremely flexible software storage services platform. Again, you're only limited by your imagination. So, of course, this now allows customers to adopt a technology that it's very, very compelling, very cost. It's very aggressive on the cost factor in the acquisition side, and allows for pretty much to meet any various use case that a customer might have today, and anything that might come down the road. So, again, I think it's a very good showing of the power of both vendors, and I think it just makes a lot of sense, and it's perfect timing now in this industry with what we're talking about. So, very excited about it.
Yeah, that is neat. Jeff, I love chatting with you. I love having you on the show. This is a true education. I absolutely love it. I have one more question for you, and I know you have to go here soon. So I'll ask this question, let you answer. We'll call it a podcast. Sound good?
Sounds good.
As organizations look at the three different deployment models, right? Traditional, converged, hyperconverged. What should they look for, and sort of consider before making their choices?
Sure. I mean, I think that's really, it may not be something that's said outwardly, but that's certainly in the minds of everybody that when they come to the table looking for a solution, right? It's what is going, as a consumer, I'm asking the question, right? What is going to give me the advantage? What is going to keep my costs under control? What's going to give me the highest level of efficiency? What's going to keep me from being boxed in? Because I think a lot of people are pretty fed up with that, right? That idea. I think that's really what has given birth to the whole software-defined, everything industry, is the flexibility nature of what we do, and the realization that things are changing and they can change independent of one another. Again, going back to what our mission statement was. So, when if I'm a consumer looking at this, again, I'm looking at those factors, and depending on how far down the road you're looking for a solution that is going to bring a very high degree of universality, if you will, right? Uniformity and consistency. And because everyone, I think, does now realize that all of these pieces and parts are highly dynamic in their nature, but fundamentally they're all the same, right? They might be faster, they might be higher capacity, it might be this, it might be that, but fundamentally they don't change the way that they operate. And of course, because of that, now I think having now, if you look at the industry, VMware was a very, very good first example of what the industry was really hungering for, right, was the decoupling at that layer. Well, now DataCore, it really is the epitome of the decoupling of the storage layer. And of course, now imagine a system, whether it be VMware or Hyper-V or any of the hypervisors, right, bringing those two worlds together and now being completely unlocked from the hardware, regardless of what it is, right? And again, your vendor of choice, your technology of choice is completely up to you. Right. So, but at the end of the day, those two technologies can run on any of the vendor platforms, with now the customer or the consumer being in control. That's a very good position to be in. In fact, the industry hadn't been in that position for a really, really, really long time. right? Looking back. So this is something that's fairly new, and it's certainly a major consideration. But as a consumer, I'm looking at the cost, the flexibility, the ease of use. Again, what is it bringing to me? How much efficiency is it bringing? Because again, every dollar I spend, if I'm a business, well, I've got to account for that somewhere, right? Every dollar I spend has an effect over here somewhere. If I'm a revenue generating company, which most are, I got to look at the impact on that. And I don't think there's any question, at least with the DataCore component, that we bring certainly the highest value economics to the table that you can possibly bring. And we've demonstrated that time and time again, most principally on the SPC-1 benchmark most recently. So I don't think there's any question there. When you look forward as technology is changing, I think the major push there is now that what everyone is seeing in the industry is that, what we've been saying for a while here at DataCore is that the worlds, although you have to bring them both together, you don't have to tightly bound them together necessarily. And that, of course, is something that I think is really contributing to the mind shift that we're seeing in the industry now. So, that's what I hear, week in and week out, every single call that I'm on, is everybody's looking for the advantage. Everyone's looking for the efficiency, the optimization, getting the most bang for the buck, as they say sometimes. That's the goal. But also, naturally, not having significant trade-offs, right? They kind of want it all, and rightfully so. If I'm running an enterprise, I want to have all the bases covered. So that's the best part about DataCore, is that we give you all that good stuff that we talked about earlier, but then we also bring ultra-high performance, ultra-high reliability, ultra-high availability, a very rich feature set. So again, we don't force you to make the trade-off, right? And that's a very good message, and I think people are really it's really resonating with people out in the industry when we talk with them. So it's a very exciting time. Hopefully, and I think you can hear the excitement in my voice, right? It's a little bit hard to contain. We're doing something very, very unique here at DataCore, and we want everybody to benefit from it.
What's interesting is that's the DataCore voice. I don't think I've done 3 podcasts where we're doing, a bunch of these things with you guys, because I love them. They're technical. I mean, just love when you guys, come on the show. In the last 3 has been as passionate and excited as I've heard in a long time. I mean, you guys are all just really, really keen on what you're doing. It's wonderful to hear, right? You can't fake passion.
Yeah, I talk to people a lot, as you know, and I think it's a rare thing. People search for this all their lives. When you can go to work for a company and you wake up and it's not work. I mean, you're getting paid. When
you find anything like that, and forget about work, just in general, a hobby that you're passionate about, right?
That's right. It becomes a paid hobby because, like a couple of my guys have told me recently, right? They don't even set their alarm clocks anymore. They don't need to. They wake up at 5, 6 o'clock in the morning and they're ready to go. And it's something new that they thought of the night before, another angle of attack, another way of doing things, another way to innovate. And if there was any word that describes DataCore, we're 18 years old, yes, but we have daily the innovation of a startup every single day. Yeah. Our chief scientists and all of our leadership and everybody has a very, very focused intention, a goal that they want to achieve, and we're now seeing the emergence of all these new great things that are coming out of Parallel IO and all the things that are still coming down the line. Right, this is just the first of many major things that we're going to be releasing into the wild here shortly, and I to say that it's exciting doesn't do it justice.
Yeah, no, that's really awesome. Jeff, that's the time we have. I really appreciate you coming on the show. I loved it. Absolutely loved it. And I think the listeners probably did too. So on that note, I'll just go ahead and give you the last word and say thank you very much for taking the time to do this. Thank you.
Yep. Thanks, Doug. Always a pleasure talking with you. And hopefully we'll have many more opportunities to talk about the next set of great things that are going to be coming out of DataCore. Thank you very much.
Thank you. And you guys have an open invitation anytime you want to come on the show and educate us the way you do. You're more than welcome. I thoroughly enjoy it. And I thoroughly mean that. So again, thank you very much. Have a great day. And just thank you very much. Take care.
Thank you, Doug. You too. Thank you.
Okay, that concludes another successful episode of DABCC Radio. As always, I want to thank my guest for today, Jeff from DataCore. Software. And Jeff, thank you so much. That was thoroughly an education. And this concludes my 3-part series with DataCore. Although if they want to do a 4th, I'm all for it. They keep sending me brilliant guys. I'll listen all day long and share it with you. So again, if you have not listened to my previous 2 podcasts, please do. The links will be in the show notes. Just go to DABCC and search DataCore. Just head over to iTunes, flip through it, download our mobile app. We have a mobile app just for DABCC Radio. We also have a new mobile app for DABCC.com too. A great solution. So just head over to the app stores and search for DABCC and you'll find them. I hope you guys enjoyed this episode. I hope you enjoyed all the episodes. Really awesome content. As I said in the intro, I'm just speechless. I really am. I learned so much. My head is spinning. So what can I say? I hope you guys enjoyed it too. Definitely check out DABCC.com for the latest and greatest virtualization news and support resources. Like I mentioned, our mobile apps, head over to the app stores, both Google, Android, and Apple iTunes, and have at those. And if you enjoy the episodes, please tell a friend. What else can I say? I'm really excited to share this one with you. Great stuff, Jeff. Great stuff, Jeff. Great stuff, Jeff. So on that note, thanks for everyone for listening to DABCC Radio. Can you say DABCC?
DABC.
Say it again, DABCC.
DABC.
Can you say it again, DABCC?
DABC.
How about DABCC?
DABC.
DABCC.
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 DABCC.